Hello, welcome to your ZM tutor, and in this video we're going to be looking at how to write the empirical formula of a compound by composition of percentage or mass. So let's say we've been given a compound. Let's say I want us to write a certain compound which contains carbon, which is approximately 40% of carbon. And then let's say it contains hydrogen 60. The compound contains hydrogen, which is 6.67%. 67%. It contains oxygen. It contains oxygen 53.3. 53.33%, yeah, 3%. So let's say you want to write the empirical formula of such a compound. So first what you have to do is that you have to write the compounds as they are C, and then you just leave a little space H and O. So now after you write that, then you write their percentage by mass. So you can just write here percent. You can write percent by mass. So this one is 40. This one is 66.67. Let me just try to get my point. And then the other one is 53.3. 53.33. Yeah. Then after you write this, you divide by their molar masses. So we know we divide by their molar masses, and we know that the mass of carbon here is 12. The mass of hydrogen is 1. The mass of oxygen is 16. So when we divide these two, we get 3. When we divide here, we get 3.336. When we divide, we get the same value, 6.67. Here when we divide, we get 3.33. We get 3.33. I'm sorry, this should be a 3. Sorry, this should be a 3. Yeah. So now when we reach this stage, we have to divide by the smallest number, which is obviously 3.33. So here we're going to divide by 3.33. We're also going to divide this by 3.33. Here we're also going to divide by 3.33. So when we divide, what we get are what we use to write our empirical formula. So when we divide here, we're going to get a 1. When we divide here, we're going to get a 2. And when we divide here, we're going to get a 1. So therefore, our empirical formula is going to be, we're going to write C, and then C, the value is 1. So it's going to be C1, H2, H2, O1, and then it's going to have O1. And then if you remember what I said in the last chemistry video, is that we don't have to include the ones that are irrelevant, right? So our empirical formula will be there for just this. Will be our empirical formula. So let's try out another question. Let me just clear this and let me get my background to black. Oh, not going to black. Okay, now let's say we have been given a compound that contains hydrogen, that contains hydrogen 20%, and then carbon, it contains carbon, and then carbon we haven't been given the percent. So what you have to know is that a percentage is out of 100. So I'm just going to say 20, 100 minus 20, which is 8. So then here, therefore your carbon will be 8%. So now we can just write the empirical formula. Hey, so up we have got hydrogen. So we're going to say, I first said we write, sorry, I first said that we have to write our elements, and then here hydrogen 20. The mass of hydrogen is 1. Here we have got carbon 80. The mass of carbon is 12. And then what do we get when we divide? So when we divide, here we're going to have obviously a 20. And then when we divide 8 by 12, we are going to get 66.7. 66. Let me just write my 6. 66.7. And then now we divide by the smallest. Which one is the smallest? I'm sure you know that this one is obviously the smallest one that we have. So we're going to divide by the smallest, which, let me just write my dividing line. So 66.7, and then here we're also going to divide by 6.67. And then when we divide by 6.67, here we're going to have 3, and then here we're going to have 1. So therefore our empirical formula will be C1H3. But I said the 1 is irrelevant, so you can just write CH3. So now let's try another example, except we're just going to have something a bit bigger. Let me just clear all of this. Sorry, let me get the background to black. Okay, now let's try this. So here we have been given the following composition. We have been given iron. We have been given a percentage. We have been given iron Fe. We have been given a percentage of iron Fe, which is 20.2%. 20.2%. We have been given S, which is sulfur, 11.5%. We have been given oxygen, 23.0. Just let me just write 23. It's 0.0, so it's basically the same. And then we have also been given H2O, water, and the percentage of water is 45.3. So we all know that all these are in percent. So now let's write our empirical formula. So I think I'm just going to go directly and divide by the molar masses of this. So the molar mass of, or the mass of iron is 56. 56. Sorry for using molar mass, that cannot apply. Okay, it can apply, but it just depends with the type of question. Now sulfur, we know that its mass is 32 its mass is just 32. Oxygen, its mass is 16. Now you have been given hydrogen. So when finding the mass of hydrogen, we know hydrogen is H2O. This is why I said molar mass. So we know oxygen here is 16, and then we've got only one atom, so it's times 1. And then here we have got hydrogen, mass of hydrogen 1 times how many atoms? 2. So this gives us 16, and then this gives us 2, and then we add. We know 16 plus 2 is 18. So here oxygen, for water, we're going to have 18. Let me just erase that. I hope it will come out everything completely. Yeah, so here we have got water, which is 18. So for water, we're going to divide this by 18. And then what do we get when we divide? So when we divide here, if you are very good in chemistry, you know that the answers that we get are a number of moles, but we're not looking for a number of moles particularly. We're looking for the empirical formula. So when we divide here, we're going to get 0.36, 0.36 for iron, and then for sulfur, we're going to get 0.36 again, 0.36. For oxygen, we're going to get 1.43, 1.43. For water, we're going to get 2.51. And then now we're going to divide by our smallest value, which is obviously 0.36. 0.36. This is also going to be divided by 0.36. This is also going to be divided by 0.36. Sorry, the point isn't showing. Here 0.36. And then when we divide, we end up here having a 1 here, and then here we have got a 4, and then here to give us 6 point something, which is 6.9. So 6.9, we're just going to write it as 7. And then now, therefore our empirical formula let me use a green. Therefore our empirical formula will be Fe. I said we do not write the 1, so I will not write it. S, it's also 1. O sulfur 4, so I'm just going to write it. And then notice we have got a 7 for H2O. So this 7 is for the whole compounds, so implying that there are 14 hydrogen atoms and 7 oxygen atoms. What I mean is we have a scenario like this: 7H2O. So this implies that here there are 14 hydrogen, and then here there are also 7 oxygens. So we are going to have, let me just put a blue dot here to show that they are separated. And then here we're going to have 7H2O. So then this is our empirical formula. Thank you for watching. This has been your tutor, ZM. Please like, follow, share with a friend. Thank you. God bless.